Okay, hi. Today we are going to have a little break from the CAN stuff, but we're going to look at HUB75. So that's one of these. This is a panel with 64 by 64 LEDs, and it's got this standard sort of HUB75 interface here, and I've actually left it wired up to the Glasgow since last time we played with this. In its current state, it's quite fiddly and annoying to wire up. So what I'd like to do is produce a little board which just sits on top of Glasgow, and then we can use a standard ribbon cable to go between the two. Hey David, and hey Mount Joy Guitar, good to see you both. Today's stream is going to be a bit shorter than normal, because sort of time, energy and everything. So yep, I will aim to probably be finishing around 12 and a bit-ish. That's about an hour or so from now. I've started a very new project for this, and my plan really is to have two connectors to Glasgow. So you've got port A and port B, and then in the middle we'll have a single connector off to the panel. Good to have you here. Okay, so if we have a look at previous or other designs, we've got, this is in the Glasgow add-ons repository that Peter or Esden has been working on. We've got his prom add-on, and we can just have a quick look at that. And here's the port A and port B, that's what we're going to be duplicating. And then all of this is going to be different for us, obviously. Looks like we've got a couple of footprint or symbol errors, but we can ignore that. So I'm just going to take a copy of this. That's one of those. Let's keep tabs on what these are. And then I'll take a quick screenshot of that just to see. There we go, I'll just keep a copy of that over there as well. Now, I've got to remember how to drive KiCad. It's been a little while. That's not the button I wanted. It is indeed this one over here. There you go. So we want, first up is the con 1x10, odd even, just like that. So we're going to have port A and port B. And they need to be positioned like this. There we go. Now the HUB75 interface is a 5-volt signal typically, but it depends on the panel you've got. So my plan here is to allow the user to configure the Glasgow ports to the correct voltage, and we'll just follow it. So I don't think there's really going to be any active circuitry on here. So we've got a couple of those. And a couple of those, that. And then in terms of VCC and ground, we don't need the VCC, so we can just completely ignore them. But we might want to feed that back for the vSense stuff, so let's do that, I think. Oops. Move that one up a little bit more in a sec. Keep it out of the way of that wire. Okay, so that's the VCC for each port, and let's label them correctly. So we got VCCA for port A, and we've got VCCB for port B. There we go. Actually put that down there. Now the grounds are easy to do, so that's just a common 0 volt signal for everything. Oops. Finish that there. And same again on the other side. Oops. Okay. We'll have a little ground power doodad. Pop that there. And we want, have we got a nice ground one? Yeah, that's the one. Whoops. So I like the triangles over the picture that's on the symbol over here. Where's it gone? This one, you know, the one with the dashes, the lines. Can I not rename that? Thought I could rename the net. Never mind. Okay, so that's simple enough. And now we've got to decode what we've got wired up here. So we've got, I think on port B we had all of the control signals, and then port A we had the two RGB lanes. So this is actually a 1/32th scan panel, which means that so it's a 64 pixels high, and it's actually broken into two halves. So you get one interface effectively to the top half, and then you get a second interface to the bottom half. And from each of those halves, which are 32 pixels high, you can then pick one line and clock the data out into that line, display it, and then you can pick the next line, display that, next line, display that. And that's achieved with, so you've got a red, green and blue set of shift registers. So if you have a look on the back, we've got here, we've got this series here, so 1, 2, 3, 4 shift registers there, and then 1, 2, 3, 4, and another 1, 2, 3, 4, just behind that that ridge. So the first one might be red, for example, the second one would be green, and the third one would be blues. And then you have a separate part which deals with syncing the current from that entire row. So if we have a look at the pinout for HUB75, I can probably grab an old project of mine. Just a second. There we go. So I've got this, what was there? LED matrix, and I've done some documentation for it. So here's the pinout that we're using. This pinout here is actually for a smaller panel, and so we've got, let's just get that bigger. Oh, sorry, here we go. So this pinout is for a smaller panel, and what we have is the red, green, blue serial data. We got that duplicated twice, so as I was saying, the display is in two halves. And then we have 4 bits of row select. So in this situation, you get 16 rows that you can pick from. But on the panel we've got here, there's actually 32 rows you can pick from. So there's an extra single bit, and that's in one of these ground positions, and I can't remember quite which one it is, but we'll figure that out in a second. Aside from that, you've then got the pixel clock, the row latch, and the output enable, and then a couple of grounds. Hey, Jikiv. Thanks for joining. So if we grab this is a 1, 2, 3, 4, 5, 6, 7, 8 by 2. If we just grab a connector for that quickly. We want a con 02x08. Let's go with odd even again. Oops. And pop it there. And I will use this as reference on the other screen. And I'll just copy out the pinning here. I thought there was a way you could duplicate things. Where was that? Never mind, I'll just draw another one. No. Tab key works with it, okay. Give that a go. Oh no. No, it doesn't seem to work here. That's a shame. How many is that then? 9. So these are the greens, and then we've got the rows, row latch. Now these last 3, 2 of those will be ground, and the final one will be an extra row select. So if I just look at what we've got wired up here, we have red, green, blue, and then it's that ground there. So this one is, that's an extra row select pin. So let's go for red 1. And let's go for blue 1. Yeah. That's going to be blue 2. That'll be green 2. And then this one is going to be the extra row. So in terms of the rows, we've got 0 here. We got 1 over here. 2. 3. And row 4. And then we got pixel clock. Latch, or row latch, sorry, and output enable. I'm being quite verbose with the labels, but I think that's right for what this is. That's 3 extra spots. Oh no. And this becomes a ground. I think it'll take me a while to get used to KiCad's selection. There we go. That was nice and easy. Now, I mentioned earlier we've got 32th scan, we've got 16th scan, and we've got 8th scan, I think, as well. So let's just look up the pinouts for those. See if anyone's done a nice little picture. Out singular, maybe that'll help. There we go. So I would like this board to be compatible with all the different scan sizes. And I think if you're, well, if you have a smaller display, you probably don't need them to be ground, but you certainly can't drive them high because they're probably tied to ground on the panel itself. I'm just trying to think. I'm sure I had a sheet from Adafruit or something. Lots of broken images. Oh no, there we go. Is that a good search term? Give that a go. Oh, neat. So we can look at their schematic, hopefully. Schematic somewhere in here. does that link us to? I know that's one of those. I thought I'd like to release their schematics. Search for the Learn guide. Sure. Learn guide, HUB75. Let's see what that brings up. Ah, there we go. This rings some bells, I think. No, never mind. Technical details link. Was that on the product page you're meaning? I did try that. I don't think it worked out though. Technical details. We got the dimensions and the weight and the ROHS certification. That's kind of frustrating. So I guess we could look at pinouts from a small display through to a large display. So there's a 32 by 32, and I'm fairly confident that 64 by 64 is the pinout that I got here, and that's quite standard. There's a 64 by 64. So does this have pinout data sheet? That'll do. No, maybe not. I hate data sheets like this. Another data sheet link. It's the same thing though. We have silk screen on the board. No. Okay, well, I'm fairly confident that for boards with a lower scan or lower number of pixels, we can just omit the higher bits. And I think if we tie them to 0 volts, that's probably fine. So I'm going to put in a jumper, 2 jumpers I think, and that will take us from 64 pixels or 32th scan all the way down to 8th scan. We had some good, so solder bridges I think are probably quite good. And there'll be 3-way bridged there, like that. Or do we want to be more dynamic than that? Let's do a proper jumper. Definitely be under con 01x03, like that. That'll do. Okay, so in here we're going to have the row 4, row 3, row 2, and it will either be connecting them to 0 or it'll be connecting them to the FPGA. If we just grab that, that can go here, row 4, row 3, row 2, like that. Otherwise they go to ground. Oops. And then we'll need another, this one here, which allows you to connect it up to the Glasgow. A bit more interactive. Let's call that row 4 internal, I think. Int will do. Ooh, can't do that. Oops. Oopsie. we go. So that will be row 2. That will be 3. There we go. And you just put a handbag on them to connect them differently. Now, in terms of port A, port B of Glasgow itself, we've got, so this will be A. Just got text under T, yeah, so that's port A. And let's make that, I don't know, 2 millimeters high. You can't do center aligned, interesting. And port B. Ah, thank you. Have a quick look at that. Oh, well done. Kind of frustrating they didn't include a PDF, isn't it? I don't have Eagle installed, so looks like they don't have. Oh, never mind. Almost looks like they generated their website from this README, doesn't it? That's quite cool. Oh, does it have an Eagle import? Let's give that a go. Save that. Let's do a new project called, I don't know what it was now. Adafruit matrix portal. And do import Eagle. Look at that. Well done. Schematic. Project destination. This one. Okay. Yeah. So there's the board. Unsupported layer. Okay, here we go. So they have allowed, I would imagine that's the one, isn't it? Yeah, there's red, green, blue. A, B, C, D, E. And they've allowed you to put E on either that pin or that pin. That's interesting. And then we've got clock latch and output enable. Okay. I think we should probably follow suit, shouldn't we? Make a copy of that. And come back and open, open our HUB75 add-on. Well done, thank you. Thumbs up it. Right, schematic, here we go. So we've actually expected this one to be ground. I'm going to call this row 4, what do we call that? Let's call that pin 8 like they've done. No, can't do it 48. Okay. And that will then be, oh, come on. That'll be row 4, pin 16. And that'll be row 4, 8. And we'll just duplicate that. 16. I think that works, doesn't it? That's not linked up properly. So the idea being that you can use as many different panels as possible. You can connect these pins to 0 if you need to. You just have 4 little handbags that you connect up as appropriate. You could potentially feed that to both places. Don't mind too much about that. Okay. I think that's good. Now let's look at the Glasgow itself. I think I might even have the stuff we did previously. Glasgow. We've got the HUB75 stuff in here. Oh yeah, this is it. There it is. Okay, here we go. So RGB1 is on 012, RGB2 is on 345. Then we've got the address on 8, 9, 10, 11, 12. The clock on 13, latch on 14, output enable 15, and we've got a default pixel width and height. So I think this applet probably needs to default to a smaller panel, just for safety reasons. But I can come back and adjust that. This applet needs a bit more attention at some point. We've got to give it more color depth, because at the moment it's only 1 bit, I think. So hopefully we'll get to that at some point soonish. So 0, 1, 2, and 3, 4, 5 are on port A. Glasgow's port A has the voltage and the sense on pins 1 and 2, and then 3 is 0. Let's just put a 0 there. And this will then be a 0 for port B, just for reference. So 0, 1, 2, 3, 4, 5 is the first one, so there we go. Red, green, oops, blue, and then we go up red, green, blue, and then these two are just not connected. We could bring them to a pin, maybe. I'm not really sure if that would give us any benefits. You know what's going to annoy me now? That's that these don't line up. Oops. Off grid, there we go. Red, green, blue, red, green, blue. Next we have 8 is this pin here, and that is the address. So shall I call it row 0, or shall I call it ABCDE or address? I think the spec technically goes with ABCD, doesn't it? Or the HUB75 stuff. Let's do that then. Yeah, let's go with that is going to be A. Oops, got a dot in there. That'll be B. C. Nope. That'll be D. That'll be E. 8. And that'll be E16. I do want row on the front of these, I think, just because I'm a weirdo. So it's swapping out the number for the letter. So A, B, C. Is that right? I forgot we had now. Yeah, row 0 and up. Oh, where's redo? Redo is control Y. So 2 will be A, 0, B, C. That'll be D. That'll be E. Okay. Oops. we got a jumper. Solder jumper with the thing bridged. One of these, won't it? There we go. Bridged. I think I'd like to go for them on A and B. We can have A here, B here, and that just allows us to disconnect it if we need and or want, but it also gives us the naming convention. So we've got A int, and that'd be B int, and I need to swap them around because we've got A at the bottom. Okay, so there. Okay, so for the address, we've got 8, 9, 10, 11, 12. 8, 9, 10, 11, 12, and that'll be A. Please give. Thank you. A, B, C, D, E. Just like that. Move these over a bit. Oops. Okay. I feel like I've done something wrong now. 13, 14, 15, 13, 14. Oh, they do line up. There we go. So then we've got the clock, the latch, and the output enable pixel clock. Latch, output enable. There we go. More space, please. What happens if we put this there? Do they line up all right? Yeah, of course they do. Okay, delete that. Oh, oopsie, and that. Okay. That is the schematic, I think. That's the Glasgow interface, that's the HUB75 interface, and that is the links between them. Might just swap these ones around so we've got the internals on the left. Give. Oh. 2 spots, I'll do it. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's good. Okay. Do we want to bring these 2 pins out to a test point or something? I don't see why not, to be honest. Let's just do that. I'm going to put them here and here. Oops. Here and here. I need to make that visible. I don't think so. If I get rid of that, then we can put test point on the end. And we can pop them in here. Yeah, look at that. Very nice. Oops. Cool. That's the schematic then. We will need now to put some parts in. So these are going to be some of this. The labels are not connected. You're referring to these squares on the end. That is actually the end of the wire, rather than the label, because I wanted the labels to be aligned on the right hand side. Because I'm special. Let's also just put a test point on these, I think, as well. Why not? Oops. Okay, come on. Thank you. Okay. Yeah, so we need to put some parts in now. So the ports A and B, they are going to be one of these. And I hope I've got the footprint ready because I'm just copying that from Peter's previous design. This one, we're going to have to go looking for. Can we do a filter? I can't remember. I just start typing. No. Connector pin socket. Connector pin header 2.54. And then we're going to go for a 3-pin vertical like that. Through hole, I think that's fine. Cool. So that's what that is. That's what that is. That's what that is. This one too. This is going to be a solder bridge. Where do you reckon that'll be? That can be under PKL. Compers. Oh yeah, here we go. Normally connect one way or the other. That'll do. Oh, it's only 2 pins, sorry. Normally connected, there we go. And that is going to be a 603, just so it's a bit more accessible. How big do we want the trace? Let's go for 30. I think that's probably 30 thou, I would guess. And then this one is going to be, I would quite like it to be shrouded. So the connectors on here, you can see have a shroud, and you can see there's the keyway there. So I would quite like it to be a shrouded connector. Let's just see if they're going to have that. Connectors. Uh-oh. Probably okay. I think we might want to go into the normal library, pin socket 2.54, and we want a 2x8 vertical with polarization. What we could do is check out the, if I save this, we can check out my other project, which is the Glasgow can stuff, because I used a polarized connector on that. This one here. And that is what? It's an IDC, connector IDC. Okay, that's fine, we can do that. Okay. On IDC. That was a 2x8, I think it was. There we go. No latches, please. 2x8 vertical, like that. That looks good. Yeah. Need to make sure we got pin run in the one in the right place. Let's see if we got a better schematic symbol for that as well. Library reference. Yeah, that's the one I want to change, isn't it? So we want polarized. That'd be 2x8, I think. No. What schematic symbol did I use on the CAN board? I'm gonna flip-flop between this one and the other one. I have to say one thing. Oh, I didn't do a polarized one on that. One thing I like about KiCad in particular is how fast it goes in and out of projects. Just bam, done. Okay, we got a polarized connector on there. I think in that case we are done with the schematic completely. Let's put a HUB75 on there. There we go. Hey Rod, we are building an add-on board for Glasgow to the HUB75. So this is a HUB75 panel. This is a 64 by 64 pixel, so it's got a 1/32th scan. I'll talk more about that in a minute, but so far I've been wiring it up by hand and it's pretty awkward. So it'd be nice to have a proper board for this. In terms of the scans, we've got 5 address bits, and we've just been looking at other products that Adafruit make, and we've seen that they have this thing here. So address E goes to either pin 8 or pin 16, so that was a good find. I was only going to put it on pin 8. So there you go, you've got Glasgow on the left, you've got a bit of configuration in the middle, and then you've got HUB75 on the right. It's all passive, only a few things to solder in. It's all through hole. I think that's good. Glasgow will drive the HUB75 panels. So this is an add-on for Glasgow. It sits on top of the Glasgow board. And then the plan is we'll just use a ribbon directly from here to the Glasgow add-on instead of all of these individual wires. I've started the applet a little while ago and I haven't really made any more progress on it, but I'd like to come back to it. So if we have a board, it'll be potentially a little bit more inviting to get going and others can use it more as well. Yeah, so let us do the ref des. Looks good. J5, J4. Oh no. Yeah, this will mount directly on top of the Glasgow. It won't mount on the back of the HUB75 panel. Does that make sense? Okay, 1, 2. I think I might turn these upside down actually. So we're going to have A at the top, then B, and we'll have C, just like that. Hey, Peter! Woo, indeed, yeah. It's been a little while. It would be really cool to have this all mounted together, but I would prefer not to, I think, at least for now. We've got things to consider, like, for example, if we've got this particular board, this panel, we've got the power coming out in the middle here. So if Glasgow was designed in such a way that it sort of fits on top like this, then you've got collision with the power. And that might be fine for other boards, might not be fine for this board. So if we were to design it in a way that works for this board, perhaps rotate Glasgow around, then maybe we'll collide with power on another board, all this kind of stuff. So I think if we can, I'd much rather just use a ribbon. Can't get it out. So here's another panel, and it's got one of these ribbons in, so that just goes from there directly into Glasgow. Oh, did the Matrix portal not receive a ribbon cable? You sent me a GitHub link to it, didn't you? Let me just scroll back quickly. There it is. So yeah, they've got this this pin header here. And I would imagine that that can take a polarized connector, but it looks like it's, oh, it's on the bottom. Ah, okay. Oh, I see, yeah, this sits directly on top. Yeah, so what we want to do is provide a polarized connector just like on the panels, and then use a ribbon. That's quite neat, actually. Hangs over the side, though. You can never win, can you? Nice. Cool. Right, so I think that's the schematic done. Just finish, tidy up. We got all the parts lined up. Let us make... Oh, I didn't finish the numbering, so this was going to be JP1, JP2, oops. And then this will be 3, 4, 5, 6. I'm going to do it in that way. 3, 4, 5, 6, 7. There we go. Yeah. It's surprising how much power you can suck out when you're doing LED stuff. It really, really is. 2, and that'll be 3, and that'll be 4. I'm just being picky about the numbering now. There we go. Okay, bring everything in. This is the brain test, isn't it? How do we do that? Update from schematic. Can't add, no footprint assigned. Okay. Oops. No, don't show it, but I do want to pick it. I think this is going to be probably from PKL. Yeah. I'll go away. Yeah, that's the thing, isn't it? 3 amps is it's kind of nothing when you're talking about LEDs and lighting like this. That's exactly it. Yeah, a wall is just absurd. I want just a test point. It's a pogo pad. Do I want a through hole test point or do I want a pad? I think just a pad is fine. I might as well make it through hole though. Oh, there's a single one. Let's just do that. Oops. Yeah. Okay, is this going to work now? Yeah. There we go. There's the HUB75. I'd like it 90 degrees, and I'd like it with the key on the outside. Got Glasgow. Oops, Glasgow is going to go on the bottom. Need to figure out which is A, which is B. We got the 2 test pads, which we can just move to one side. 3 test pads, 4 test pads, and then we've got the config. I think those will sort of make themselves known in a minute. And then the other addresses. Right, okay. So this is the top of the board. Port A is J2. Oh dear, can I allow that to happen? Port A is J2, which is that one. On Glasgow, port A is, which way up is it going to go? This way. So we're going to keep Glasgow the right way up. Port A is the top one, which means that it goes there. And I think pin 1, I think is the, I remember now, pin 1. Pin 1 is on the inside. Oh, this is not on the bottom yet. There we go. Put it on the bottom, put it on the bottom. How do you do that? There we go. That's better. Put it on the back. Okay. Line those up. Now, that's something we'll need to come to, is the spacing. I'm going to get yes, I'm going to get Glasgow open as well, just so we can refer to it. So we have, oh, give me the pin 1, here we go. There are a few more, are there? We have taken account for, I think, a 4th scan all the way through to 32th scan, and we've put address or row E on pin 8 and or on pin 16. So hopefully that does it, or are you referring to other connectors that are not HUB75? Cool. Right, so that's 35.56. I'm tempted again to refer to the RAM pack board. Well, not the RAM pack, the PROM add-on. That's got a nice outline, but it's also got these positioned correctly. If we go for that, and then if we go for that, I think they're the same footprints, aren't they? We should be set. I'm going to rename these because this is going to confuse me. There you go. And I'm probably going to have to redo this as well, aren't I? Let's just name these A2, A1. Push the button, see if it blows up. Is that how we do this? Oh, it did. It did. It reverted them. So the J1 is A. J1. Oh, no, that is correct. J1 goes on the top. That's port A. Okay. Put that wherever we like. Now, that pin there. 156.8, 103.5. That's that pin, isn't it? Yes. So if we put that at 0, 0. Oh, you probably can't do things at 0, 0, can you? Let's do 100, 100. Yeah, the spacing's a good one to get right. So I put this one at 100, 100, and I want to lock it in place. I'm not sure if you can do that in KiCad. But that's it, pin 1. Locking, lock. There you go. Nice. No. Then we've got 22.86 and 35.56. I'm never going to remember those. 22.86 and 35.56. There we go. So that's where this goes, and this is going to be 122.86 and 135.56, like that. That looks good, I think. I want to lock it in place. Locking lock. Okay. This one then will nicely fit in between, which is awesome. Just where I would like it to be. Let's turn off some of these. We've got fabs. We've got, where's that grey, do you think? It's on the front fab, there we go. Okay. Now then. Oh, I'm pressing all the wrong buttons now. I want to write a wire down. Here we go. Route tracks. Nope. I can't remember what the keyboard is for that. Oh, it's on the other side. That's annoying. Just go for it, really, I think. Tab. How do you change layers with this? Back copper. No. I have forgotten. Route, single track, Shift X. I'm sure it wasn't that previously, was it? Shift X. I mean, okay, but that goes off to a config thing, config thing, config thing, config thing, config thing, okay. Let us put that between there. Not in the middle, but I don't think it will be on the grid we've got. What grid have we got? We got that. I don't remember how to change the grid of the keyboard either. That's depressing, isn't it? 2.54. Go for that grid. Better. Oops. Oh no. I think this is the one we want, and this is the one we want. Yes, well done. Okay. Now we want these, and they have to go far side. Oh, these are the RGBs, aren't they? I had to get rid of all of them. No, don't go around there. That's the first one. We got the next RGB. Okay, something like that. RGB. Oh, there we go. And then, oh, these are the test points, so we can move them up. They don't need to be anywhere near as far away. Oops. I'm not even sure they need to be test points, to be honest, but they can stay. And I think we might also want to move. Oh, that's annoying. This, I can't get that, can I? There's no way to align that with that without, okay, without making the grid different. Let's just put them somewhere else then, like there and there. And we don't have to move everything around to accommodate them. That's fine. Now these ones, tidy this up a bit actually, can't we? Oh. Yep, hold on. How do you make it do the other way? Draw it the other way up, okay. Oh, come on. I did not give you... No, didn't give you an excuse for that. There we go. Maybe. That's the one. There's the RGBs. Now we've got the... What is it? It's the... Here it is. We've got the output enable row latch and the pixel clock need to come from here. I think we just hop underneath this. How do you change layer? I don't know. No. I want to add a wire. Oh, is it page up, page down? Give that a go. Page up, page down. No. Oh, it does actually. Oh, hang on. So that does actually change the layer, but it doesn't seem to put a wire in and let me root on the next layer. It just reverts as soon as I click again. Control, Shift, Alt, scroll wheels don't work. Not even sure I know how to put a wire into it. Oh, add wires there. I could just do it the really long-winded way, couldn't I? Yeah, go on then. Delete that. Or is there still a little bit left? Okay. So we come out of here to there, go to there, and we want to via. V for via. Ah, look at that. And that's way too small. I would guess, at least. Nope. What kind of a via is that? Oh no, that's fine. 0.4 millimeters. That's all right. We can deal with that. Row latch. The connector pins are, yes, but I was planning on putting just a flood of ground on the bottom, so I don't want to run for too long on the underside. That makes sense? Yep. And then this one. Oh, not going to be able to get out of that, are we? Whoa. Oh, the magical placement decisions that KiCad makes are a bit frustrating. We go the other way. There we go. Maybe. Oops. V. I don't feel like that's on my angle, is it? No, it's not. Yeah, not all boards are 4 layers. This is just going to be a basic 2-layer board. No need for anything more for this one. So those are all the addresses. We've got 2 E's. Okay. Where do these ones go? I think this is A and B. There we go. I think on the top is alright for these, isn't it? This is A, which is there. This is B. Give me the whole thing. Ooh, should we do a 45-degree thing? Make it all risky. 45? Yes, that's right. not risky, but edgy. That's what I'm after. We can make it like 13 degrees or something as well, to make everyone super happy when they see it. These fires are definitely going to need some attention. Now then, all of these, don't know where to put them yet. These grounds can go on the far side, so we can rotate that around, that's easy enough. And then we've got C, D, E, E. That will be the top E. And then this one, and then D, and then C. I think. So E. Oh no, they're going to be all funny order, aren't they? But it'd be nice for the human that's working it to have them in the right order. But let's keep them in that order. So yeah, so E, 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 D, C. I think we might have to rip up some of these things. Oops, just to place it. Oh no. No. Okay. We could get the RGBs down in between it, possibly. Could do that. Looking for a nice compact solution here. We're actually going to those pins there, so if we bring that to here, we can bring this RGB around the front, space them out a little bit. And then align them again, just because that kind of thing matters to some people, doesn't it? Some people like me. Get rid of them. Get rid of them. We have E. We have a, what's that? Oh, that's a latch, sorry. Got a D. That one, yeah, that's okay, we can do that. Come on. Behave. What? And then we've got a B. Oh, that goes off to one of those thingies. C here. That's good. This is the one which is going to have to cross a RGB channel, I think, with a via like that. Right there. And then a B. Oh, the other E. That'll go over here. Rat nests are quite bright in this. You've got all these internals. They can just come out the bottom. That's common with that. Oops. skip this song. Going a bit slow, isn't it? Should I just use up the bottom as well? Be nice to not do that. We can bring all these through here. I think they'll all fit. Oh. Oh, missed an end of that one. Can you? Yeah, there we go. Do this one. Do this one. They're quite close, but I think it'll be all right. Yeah, I've actually got a little bit of space in there, but we'll probably need to bring this one out. Yeah, like that. Bunch them up a bit. And we got row B and row A can squeeze out of there, that'll be fine. That's ready for an RGB channel down there. Be a nice little cutout, but never mind. Oh, I see what I was trying to do previously, yeah. Try and keep that, I think, as best we can. In that case, let's move it down. Oops. See if we can squeeze this RGB channel through here. Oh. Yes, no worries. Bottom, there we go. That is, oh, that's the blue, okay. These RGB channels, row A, row B, row C, they're all just here. Kind of wonder about just bringing them straight through on the bottom layer. Do that, see what happens. We can always put straps over the top, don't forget. Not exactly super critical design this. Oops. Oh. that work? Yeah, that's good. Yeah, Mum. See that I was pressing earlier, doing something with X, I think maybe. Now, come on. There we go. Okay. I'm going to bring this back on top because then we can bring the other one down. Row D can come down here on the bottom there. Oh, come on. That's all good then. The ground is not an issue, we just ignore that one. We've got A, B, D, C. Where's E? He's stuck up here. Let's draw that on the bottom and bring that down as well. That's good. I mean, they're in the wrong order, but we can probably resolve that in a second. Take these off the slant. There you go. No. What? If. Oh, it's because they're over the top of each other, is it? And the square bounding box is giving giving you problems rather than a rotated square. It's a direct square. Okay. That's good. We can shift that over so it's not underneath the footprint of the connector. Okay. Let's bring the RGB around then. No, come on. That's good. The other channel. Give. Okay. So we got the clock, latches, and output enable, and that, I think, that will work okay if we just go directly under here, won't it? Of course, it's not on grid for some reason. Of course, it's not on grid. Really, really not on grid. Oh, is that because I've butted up against the other track? It's kind of annoying. Tell you what, we can do that. Come on. There you go. So 1, 2, 3, 4, 5, put a via there, plonk. Got to have some good consistency in your designs, haven't you? Pixel clock. I get the feeling that KiCad doesn't really like it when I zoom out and I'm drawing a track. Okay. Oh, getting there. Not been too destructive on the ground, playing on the bottom. Might be able to remedy some of it. I think we got to untangle these, and I think by untangling them we can probably get away with doing some good things. So this is the D, I think it is. No, it's not, it's the E. And I think if we just delete that, we can bring it on the top layer from here. Yeah, it does help, doesn't it? We can bring it between those pins. Between those pins, yeah. Put a fire there. Oops, I dropped it. Give me it. Thank you. Between those pins, and then put another wire here, and then pretty much directly into that pin there. This is then backwards, but we can draw that directly on the bottom layer, between here, straight into that pin. Boop. Nice. And then this one goes straight in, and we can, well, I can bring this one on top layer again as well, actually. Let's do that. Via there-ish, and straight in. This one on the bottom layer, via there-ish, straight in. There you go. I'm going to move these into position now, so I'm going to put that there, and that one up there, temporarily. Oh, we're getting there. Let's get rid of some more of these. So we've got pastes, silks, masks. Well, after now, that'll be the courtyards, there you go. We want to get rid of as much green as we can. I can bunch these up a bit, I think. That's probably nearly the best we can do around there, I think. We can bring this channel up, potentially. Not sure it would necessarily be worth it, though. We can definitely bring this onto the top layer and back onto the bottom layer. That would help. Let's do that, even though it's only for a short run. I think it's not ideal if you're sort of concerned about your signal integrity, but actually, no, let's not do it over there. Yeah, I mean, you want to reduce vires if you're dealing with particularly fast things, but this is a row signal, so I'm not too concerned, I guess. The alternative is to put a strap. So basically what we've done here is we've allowed the bottom layer, the green layer, to flood around here and sort of increase the integrity of that plane. Oops. The alternative to doing that is to put the plane on the top as well and then strap it with a bar across the top. But I think what we're doing here is okay. Let's see if we can get those wires any closer. Oh, lots of wiggly bits going on. Yeah, that's better. Probably get rid of that wiggle as well. Get rid of that wiggle. Bring this one closer too. I think I might be getting towards the end of the stream for today, but it's looking good. Yeah, let's bring these in. Just using the default rules, but I think, let's see how big this track is. That is 25.25 millimeters. In thou, because my brain works that way, I'm afraid, is 10-ish thou. That should be fine. If we can get rid of that wiggle. Yep, that's good. Okay, let's bring the courtyard back and the top silk. Where is it? Top silk, front silk, there we go. Okay, so this can't actually go underneath the footprint there, but we can bring it to about here. I think that's fine. Seems like it's aligning on something. Oh, now. I'm not sure if your /s is a sarcasm disclaimer, but one of the things that really winds me up is when people refer to thousandth of an inch as mils, because it's impossible to determine without context if they're talking about millimeters or thou, basically. So yeah, that's a good way to wind me up, is to just use mil. Yeah. Oh, I don't like it, Come on. I think I worry too much sometimes about the quality of my drawings. That'll do. Nice. Now we just got ground to do and those 2 test points. That's awesome. Let's line them up, I think, if we can, with... We can't. We can, however, use this, so that's 135.56 to go in this box. There you go. Oh, it's moved it. Oh. It moved it inside its symbol. Here we go, that's better. Do that and do that. The next thing we want to know is how far away it is, so there we go, that's better. 1227 is 5 millimeters, isn't it? There's 100, and we're going to want it at x95, 100. There you go. So the VCC isn't actually used at all in this design. tell you what, let's not put it there, let's put it down here because there's space there. That's going to be 100 and 105. There. We're doing all three. Have a look at it. That looks alright, doesn't it? Need to label it up. Put a nice board outline off on it. Let's do some quick labels. So 3, 4, 5, 6. I think they were 3, 4, 5, 6 is C, D, E, and E. Now the E one is difficult because we got an E to pin 8 and an E to pin 16. So I think all of them need to identify which row bit it is and also which pin it will connect them to. So why don't we add that in here? So this will be A9. A9. That'll be C11. Just for clarity, that'll be B10. And that'll be D12. So C11. D12. E8, E16. A was 9. And B is 10. Cool. Bring those changes in. Blink. Okay. So the left hand side is ground and the right hand side is to the header or to the HUB75 connector. So I think, how do we mark that up? And we can get rid of these. Don't really mind too much about getting them out of the way. J7 can go away. J2 and J1 I'd like to keep just because they identify the orientation on the Glasgow. I'm going to put an A up here, I think. So we just do a text A. And that's going to go on the top silk. Front silk. What have we got? Give it like 2.5 millimeters, so it's really obvious. It's there. Copy that. Let's put it on the bottom actually, that's a good point. Bottom silk. Do we need to mirror it or will that happen? Let's find out with the B. B. Yeah, it needs to be mirrored. A is there, B is down here, like that. Good, that looks right. Yeah. I'm still not sure about these ones. How much space have we got? We got a bit of space, so we want to say what it is. So E, E, D, D, a C, sorry, and then which pin it goes to. So that would be 16, 8, 12, and 11. So I'm thinking if we put E on the left, like that, E again on the left, front copper. Can you change that? Silk, please. Gonna have to sit on top of that via. That'll be D. And that would be C. The left-hand column is just all grounds and the right-hand column is the connector. I'm thinking if we do a text here that says 16. Not super clear, is it? Oh, it doesn't. Oh, does it fit? About 16. That's 8. If I just make front silk active, there we go. Does that mean that the next one? Yes. 12. Oh, it's gone small. Of course it has. Why was that? That's now 1mm instead of 1.5. Maybe each layer has its own thing. Oh, and it's gone different thickness as well. 0.3. This one is an 11. That's annoying. Not super clear, is it? If we make them smaller and see if they actually fit between, that'd be quite good. From the can board, I think we got away with a 1mm text height, did we? Or is it this one? No, this one. Front silk. This one is how big? 1.6. I remember being quite surprised at how large it actually was. That's 1.2. Let me just grab it. Oops. Oh yeah, that's huge. So that J9, for example, that's a reasonable size. No, the J9, thank you. That's only 1mm, so 0.15. Okay, let's do that then. I get it. In here somewhere, here it is. And I think we could probably get away with moving that to... Oh, that's very tight. It does fit though, look. Yeah. Let's do that. So that's that, and then that would be ground. Oh, hang on. Got those the wrong way around. That's E, and that's 16. This is pin 16. Does it go to ground, or does it go to E? I want to rename that 0 volts. Yeah, that looks good, I think. I do lots of these at once. You found it. What did you find? HUB12. Uh-oh. Just as we're finishing up. Have you got a link to the pinout or something, Peter? That'd be quite cool. Oh, it should work with. Okay, that's cool. Thank you. Grab that in here. Amazing, isn't it? Look at at the pixel pitch on that. Okay, so hub 12. Oh, here we go. Oh no, that's very different. That's a P10. Yeah, I think that's very, very different. We've got clock, data. Oh, clock, S clock and data. We've got an A and B. Oh, store clock, so that's the latch and the clock. Okay. It would be good to support this too. I've done all the layout now. I thought we were going to be okay with all the variants of the HUB75. That's true. A and B. So A and B here would pick, or pick the row. So that'd be like a 2-bit row select, would it? Are these RGB as well, or are they just a single color? It looks like a single color. Just red, yeah. Okay. So in that case, not quite following how they're wired up or how their sort of orders go. Because obviously with the HUB75 stuff, you've got a shift register, you've got serial inputs for each of red, green and blue, and then you also have a row select. Whereas this, it looks like it's got a 2-bit row select, but it's got 1, 2, 3, 4, 5, 6, 7, 8, 16 rows. So perhaps that's then broken up into 4 chunks. So what you shift in like 4 rows at a time, perhaps? I don't know. I'll put this in my list to look at. Thank you for talking about it or mentioning it. Oh, agreed. Yeah, just trying to understand what it does, how it works. I'll finish just placing these, and then I think I'm going to call it a day. But yeah, I think it'd be good to come back to this and add in that connector before I go to make one of these. Yeah, that's that. Oh, have I got an odd spacing here? I think I have. This one's got extra gap. Never mind. That's good for today, I think. We'll leave it there. Let's try to add in this other Hub10 or P10 or whatever it's called. P10. And you mentioned there was another one as well, Peter. Hub8. Hub12. Hub12. And Hub8. I will take a note to look into them. Oh, that didn't paste very well. unless that's a genuine link. Oh no, it worked. Well done. This looks... this is HUB08, okay. HUB12, HUB40, HUB75, nice. Yeah, that's different again, isn't it? And that's going to be a 2x8, which I think is... Yeah, 2x8, so that's going to be physically connectable or compatible, but electrically not. At this point, potentially, this is one of the cool things about Glasgow, is that you could just wire up each of these individual pins to a Glasgow I/O pin, and it can be just a 16-pin connector, and you can be completely flexible without anything else. Because the issue here is that obviously you've got all these connectors which are indeed the same, or sorry, exactly the same, and there's no way of knowing what panel it is you've got and how to connect it without trying it, I guess. See if anything blows up. I'm going to save a page. I'm also going to take that link, but it might not paste well into KiCad. Yeah, yuck. Never mind. Cool. Yeah. I think I'm going to leave it there for today. Thank you everybody for joining. We have got the schematic, at least for HUB75. Be nice to add in the others, or at the very least to just connect up. I guess it's only really 2 pins extra. I don't know if KiCad supports it, but I wonder if Chrome just sees like a text copy and just smushes it. But yeah, so I think that's looking alright today. Some stuff to do still, and I think I will. So I'm doing this as. Oh, thanks, Peter. I'm doing this as a PR one day for your Glasgow add-ons repository. So I need to do a board outline, probably add a couple of other connectors, or make it as flexible as we were talking just now, so that you just have like digital control of each of these pins. That could be quite cool, to be honest. Anyway, yeah. I will leave it there. Thank you everybody for joining, and hopefully I'll be back back before too soon. Don't know. Oh, I look a bit stretched. Am I stretched? Hopefully I'll be back before too soon, and yeah, see you then. Bye bye.